In 1969, the first human beings to walk on another world returned home. NASA didn't greet them with a parade right away. Neil Armstrong, Buzz Aldrin, and Michael Collins spent their first 3 weeks back on Earth, sealed inside a quarantine facility. This isolation was mandated by a lack of information. Scientists didn't know if the moon carried biological threats. They simply couldn't prove it was safe. Our current objective for Mars moves past the dust on a spacesuit. We are now preparing to handle deliberately sealed pieces of ancient Martian geology. Bringing this material home forces a decision on whether our biosphere should be exposed to contact with a world we have yet to understand. The Perseverance rover is currently executing this task. It is driving across Jezero crater, drilling into the terrain, and sealing physical records of the planet inside specialized tubes. Jezero crater contains these visible river delta and fan structures. Billions of years ago, liquid water flowed through this basin, creating an environment capable of preserving microscopic biology. While a rover is a marvel of engineering, its instruments are limited. To analyze the exact chemistry and structure of these rocks, scientists need the massive, highly sensitive laboratories located here on Earth. Scientific accuracy requires a strict boundary here. Identifying a promising biosignature on Mars is distinct from confirming an alien organism. By returning these samples, we are purposefully introducing the possibility of ancient alien biology into the immediate neighborhood of everything currently alive on this planet. Getting those samples to a laboratory is an immense logistical challenge. A vehicle must launch from the Martian surface, rendezvous with the spacecraft in orbit, cross interplanetary space, and survive atmospheric entry. Throughout that journey, the mission operates under the rules of planetary protection, a policy designed to manage the uncertainty of cross-contamination. The first priority is protecting Mars from us. Earth is overflowing with biology. If a single stray microbe contaminates a sample, it destroys the exact evidence the mission was built to discover. The second priority is preventing any potential unknown Martian material from escaping containment and entering Earth's environment. These goals create a contradictory engineering requirement. We must build a facility clean enough to keep Earth's biology out, while remain secure enough to keep Mars in. In 2026, researchers Frederick Moxley and Anthony Ricciardi proposed a radical solution: intercept the samples before they ever reach our atmosphere. Their plan redirects inbound Martian samples away from Earth, routing them into lunar orbit. The material lands at a secure robotic facility on the moon. Automated systems conduct all biological testing, transmitting data back to Earth, while the physical sample remains strictly off-world. The researchers base this extreme isolation on the history of Earth's ecology. When organisms enter an environment with no natural biological defenses, the consequences are unpredictable. The lunar firewall serves as a structural response to absolute biological uncertainty. To understand this debate, we have to look past Hollywood horror scenarios. The probability of an active, dangerous pathogen surviving on the modern Martian surface is incredibly low. Mars today is a hostile environment. The surface is freezing, irradiated, and entirely lacks stable liquid water. Furthermore, Earth and Mars have already been exchanging rocks for billions of years. Asteroid impacts routinely eject Martian material into space, and some of it eventually lands here. Nature has already run this cross-contamination experiment billions of times. The extreme protocols surrounding sample return exist to ensure a pristine, tightly controlled scientific investigation. The true difficulty begins after the physical container arrives. What happens if scientists open a sample and find an unexplainable chemical pattern? How do you definitively prove an alien biosignature is real when humanity lacks any biological baseline for comparison? The burden of proof would be immense. A negative result simply means we didn't find evidence, but a positive result will demand years of agonizing independent verification. Returning these samples will require a level of scientific interpretation humanity has never had to provide. Beneath the engineering anxieties and the containment protocols lies the core human desire driving this effort: the need for an answer. If we analyze these rocks and discover that life evolved independently on Mars, the implications stretch far beyond our solar system. Finding biology twice on two neighboring worlds would prove that life is a constant and repeating function of the cosmos. We are not bringing Mars home because we are afraid of the unknown. We are bringing it home because we need to know if we are alone in the dark.